includes direct integration, substitution, replacement before direct integration, method of characteristics, and separation of variables. Okay, so this is an example of first order partial differential equation. So we initiate if certain formula z of x comma y equals to x of x, y of y, and in here we differentiate this equation. Let's call this equation 2. Let's call this equation 1. We differentiate this equation with respect to x, such that we have partial z partial x equals to the while we differentiate the other part, and we get which is equals to x of x dy over dy. So now we substitute this with this partial z partial x. Partial z partial x is equals to this. So we substitute this one with this one, substitute this one with this one, with this one. So now we get this one, which is equals to 0. So I haven't divided, I haven't done with the division, dividing this equation by y cube, both this side and this side by y cube, x squared, this one and this one, then we get this. So what we do now is to move this one to the other side. So then we have 1 over x of x squared, the x equals to minus the y 1 over y cube So from here, let's just pick the first term and equate it to a constant. So we have 1 x of x squared equals to, then we equate it to this k. So what do we do next? We separate it such that we have 1 over x of x, or let us put 1 over x, then the x equals to k x square dx. Then we integrate both sides. Integrating both sides. So we get ln x equals kx square or cubes, rather kx cube over 3 plus c1. Then we find our value for x, the value for c1. We then have, so we'll find the exponential of both sides. We have e raised to the power of ln x equals e raised to the power of kx cube over 3 plus c1, where we have this guy cancel this, and we have x equals to e raised to the power of kx cube over 3 dot a. So solving on the other side, we have negative dy the 1 over y of 3 equals to k. So from there, so we just cross such that we get dy 1 over y is equals to k dy. That's ky cube. So we integrate both sides. Integrating both sides, we have ln y dy, ln y equals to k negative, it's a negative sign here because it is they are cross multiplying, so k y raised to the power 4 over 4 plus c2. So from here we use our exponential, ln y equals exponential negative ky 4 over 4 plus c2, where our c2 is b. So where our is same thing as exponential ln y equals exponential negative ky raised to the power 4 over 4 multiplied by it is same thing as dot exponential c2 is a constant, so we can then just put b there. It's the way we do for this one. So you can just put b as the constant, representing the constant. So from there we finally get b as our EC2. So from here, don't forget EC1. So finally, I haven't gotten that. What we just do next is just to go back to the equation, then we put our z of x and replace them with the value for a and b, such that we have a kx raised to the power of 3 over 2 over 3 dot exponential negative ky raised to the power of 4 over 4, and which is where p is equals to a cross b. So this is a solution to I actually use a separation of variable is solving first order partial differential equation. So let's go to the next.